So for this problem as a review, we are going to graph this quadratic function and it's currently in standard form. So you can refer back to these notes. These can be used for homework, but you cannot use this on a test or a quiz. So the first one is we want to make a prediction. Is this parabola opening up or down? Because A is positive, it opens upward. Step number 2, I want to identify the axis of symmetry. The equation is x equals negative b over 2a. So I substitute in a -7 for the b. But when you substitute in a -7, there already is a negative in front, which actually turns this into a positive. So x equals positive 7 over 2. If you need to use a calculator, feel free to do that. 7 divided by 2 is 3.5. Now you go to your graph and you identify where positive 3.5 is on the x-axis. Your axis of symmetry or line of symmetry, those are interchangeable terms, will always go through the x-axis with functions, with quadratic functions. 1, 2, 3, 3.5. I have completed steps 1 and 2. Step 3 says, let's identify the vertex. So the vertex is an ordered pair. It's your minimum or your maximum. You already know what the x is. The x value comes from your axis of symmetry. So let's figure out what is this y value. To do that, you're going to take this value of 3.5 and I'm going to plug it in wherever I see an x up above. Now in this case, we're going to use the calculator to do this. For today's quiz, you will not be allowed to use a calculator, but let me tell you that this will not be a decimal. So it'll be a nice whole number or an integer. So it'd be like a 2 or a 3 or -1. Here we go. I'm going to do 3.5 squared minus 7 times 3.5 plus 5. I've taken the equation that I was given. I've substituted in the x value wherever I see an x in the equation. This means that y is -7.25. If you were asked to identify the vertex, this is the coordinates of the vertex. I come over to my right. 1, 2, 3, 4, 5, 6, 7. So here's 7. Between 7 and 8, about 7.25. There is the vertex. I've completed steps 1, 2, and 3. Step 4 says to identify the x-intercepts. So to identify the x-intercepts, you have two options. One option is to factor this if it's factorable. Not every equation is factorable. But what always works is the quadratic formula. So let's first take a clue here. 1 times 5 is 5. Can I think of two numbers that multiply to equal 5, but add or subtract to give you -7? Is that possible? Well, the only two numbers that multiply to give you 5 is 1 and 5. Does 1 and 5 somehow add to give you -7? Okay, so if it's not factorable, we're going to turn to the quadratic formula. This has to be memorized. I'm going to pull the numbers 1, -7, and 5 and place them to the quadratic formula. Two negatives make a positive. -7 squared is 49. 4 times 1 times 5 is 20. All over 2. On Friday, we talked about the discriminant. For those that missed class on Friday, the discriminant is simply b squared minus 4ac. Forget about the square root. It's just b squared minus 4ac. And on Friday, we learned if this number inside the radical is positive, how many real roots or x-intercepts will we have? Look in your notes if you don't know. If the discriminant is positive, how many real roots, which are also called x-intercepts, will we have? 2. So I know there's going to be 2 x-intercepts. What if this number was 0? How many would we have? 1. And if this was a negative number, we would have no x-intercepts. Okay, so I know I'm going to have 2. Now, how do we get those 2? We're going to grab the calculator and go 7 plus the square root of 29. So I've completed the numerator, and I'm going to press enter, and now divide by 2. We're going to round to the nearest tenth. So 6.2 approximately, 6.2. So one x-intercept is 6.20. 1, 2, 3, 4, 5, 6, 6.2. The second x-intercept, now I'm going to subtract. 7 subtract the square root of 29 divided by 2. Rounded to the nearest tenth is 0.8. 0.8, comma 0. So here's 1, 0.8 is about here. I just want you to notice that from the axis symmetry, because we know a parabola is symmetrical, it's the same distance to the right to this x-intercept as it is to the left to this x-intercept. Okay, we've done all of the hard work. Now let's identify the y-intercept. The y-intercept comes from the number in the equation that contains no x's. In this case, it's 5. 1, 2, 3, 4, 5. Your y-intercept is 0, 5. Your y-intercept is 0, 5. Now using the concepts of symmetry, if this is 5 away, I get to go 5 to the right. So here we go, I get to go 5 to the right. I'm at 3.5, 4.5, 5.5, 6.5. Let's go here, whoops. Sorry, my fault here. This is 3.5 here. 5 up, but it's 3.5 from this point to the axis symmetry. So 3.5. 3.5, there's 1, 2, 3, 3.5. And these are the same distance. Connect. With your partner, I'm going to state right over here, I'm going to state the domain first and the range second. I'm going to put it on paper. With your partner, you have 30 seconds to write down what is the domain, what is the range, and then look up here to check your answer. Begin. The domain for all parabolas that are quadratic functions is negative infinity to positive infinity because there's no limitations how far this goes to the right or to the left. Remember, this is going up at an angle. So as it moves up, it's also being pulled to the left. That makes it go at an angle. And as it moves upwards, it's also being pulled to the right. That's why it goes up at an angle. The range, we go from minimum to maximum. So the minimum y value, this y value here, looking at the y value here, would be negative 7.25, and there's no limit how high it goes. Negative 7.25 is part of the function, so we include it, and we can't touch a positive infinity. Can I have thumbs up or thumbs down for your understanding of domain and range? So I can see right now thumbs up, thumbs down. Okay, here's the next one. We are going to, please listen. We're going to do intervals of increasing and intervals of decreasing. It is my suggestion that you write on your paper before you answer the question. We always read it from left to right. So I start at the left point. Think of yourself on a skateboard and a bike. Are you going up or down from left to right? Down, so I'm going to write decreasing, and I'm just going to abbreviate. When you get to the very lowest point, you're neutral. You're not going up or down, but as you continue to go to the right, now you're increasing. There's two things you have to remember when identifying increasing and decreasing intervals. The first is they're always written with parentheses. Always written with parentheses. And the second is we always use x values to describe them. So I'm going to write increase and decrease here. So where is it increasing? Well, it starts at an x value of 3.5, and it continues to go to the right with no limits. Always write them with parentheses. Decrease, it comes from the far left with no limit how far it goes to the left, and it continues to go till it gets to an x value of 3.5. Give me 1 second. All right, next up, turn to your partner, and I would like you to write down what is the equation for the axis of symmetry, also known as the line of symmetry. 10 seconds with your partner and put it on paper. What is the equation for the axis of symmetry, also known as the line of symmetry? The axis of symmetry or line of symmetry cuts through the x-axis at 3.5. It is x equals 3.5. If you put 7 over 2, it's the same thing as 3.5. Okay, your next part is I would like you to write down what is the what is the end behavior. End behavior with your partner. When you're done, please look up here to check. Ready, begin. Make sure you're putting it in the correct format. Okay, so I start by putting as x goes to negative infinity and to positive infinity. Those are always there for every problem. What does this mean? As I go to the far left of my graph, which way is my graph headed? It's headed upward. And as I go to the far right, which way is it headed? It's headed upward as well. Here is my end behavior.